Hello, welcome back to my channel. I am Xavier Smith, and today I'm going to talk about the flow of energy in an ecosystem. So let's start with our organisms. We start with the two broad categories, autotroph and heterotroph. So an autotroph makes food from sunlight and organic materials, or just inorganic materials like sulfur. And these autotrophs are our producers. They are the bottom level of our food chains, food webs. Our heterotroph gets energy from consuming other organisms, so our heterotroph is the consumer. Now, there are these four types of heterotrophs. There is the herbivore, which eats only plants, the carnivore, which eats only animals, the omnivore, which eats both plants and animals, and the detritivore, which eats fragments of dead material. Now we are going to talk about food chains and webs. Each step in a food chain or food web is called a trophic level. This also works for ecological pyramids. Now, the food chain is a simplified version of a food web. It just shows the flow of energy being transformed and transported throughout organisms in an ecosystem, but very simple. An example would be, well, it goes from producer to an herbivore to an omnivore to a carnivore. This is the producer. Then there's the primary consumer, then the secondary consumer, and the tertiary consumer, which is like the apex predator. It has nothing that comes after tertiary consumer. So it would be like a plant. Then a grasshopper eats that, a mouse eats the grasshopper, and a snake eats the mouse. Now, a food web is a more complex diagram. It shows many more organisms, many more relationships, many more transfers of energy from different organisms. So it is a lot bigger, and well, it does basically the same thing as a food chain, but it shows a lot more different ways energy can be transferred. So here we just have like, oh, grass goes to jackrabbit, goes to coyote, or the cactus just goes to the tortoise, or the lizard goes to the rattlesnake, goes to the raven. Things like that. And then they keep traveling always to these tertiary consumers, which are the raven and the coyote. Now, finally, we're going to talk about ecological pyramids. So an ecological pyramid can show the relative amounts of energy, or the amounts of biomass, or the number of organisms at each trophic level. So each of these trophic levels, it's going to show that either available energy is going to decrease while you go up, available biomass is going to decrease while you go up, or the population size is going to decrease while you go up from this producer, primary consumer, secondary consumer, and finally to your tertiary consumer. And biomass here is the total amount of living matter available at a trophic level. So for relative amounts of energy, you start, let's just say the plant has 100% of the energy. At each level, plant's going to use some energy, then some heat is going to be left. And it's going to keep going. Each organism is going to use some energy, and then heat will be released. So 100% of the energy is in the producer. Then, at the primary consumer, they only get 10% of that energy. Heat is used, all the metabolism of the plant went on, and now they get 10% of the energy. Now the secondary consumer gets 10% of that, and then finally, the tertiary consumer, or like the apex predator, gets 0.1% of that energy. So available biomass would be, well, let's just say 809 grams per meter squared. Then when we go up, it goes 37 grams per meter squared. Then 11 grams per meter squared. Then 1.5 grams per meter squared. Now, like population size, you start with 1.5 million producers. Then primary consumers, well, you only have 200,000. Like you'd only have, in this area, you'd have 1.5 million plants, then 200,000 grasshoppers, then 90,000 mice, and we could say 5,000 snakes, which seems like a lot. But that is ecological pyramids. If this was helpful, please like and subscribe. Thank you.